Okay, we're recording, and I'll share the screen. Okay, quick word about the quiz. All right, so now you've seen one quiz. They're all going to be sort of like this. I mean, it's not really even a quiz. It should really be classified as an in-class assignment. It's a lot shorter for me to just write QUIZ than to write INCLASSASSINGMENT, right? So it's a quiz where you get to help each other out and all that kind of stuff. All right, now for number one, to me, the easiest way to write the answer is all real numbers minus a set consisting of 5 and 6. Okay. Now, some of you wrote it in, interval notation like negative infinity to 5 union 5 6 union 6 to infinity. I accepted that. I actually don't prefer it, and to me, it's harder to read that. Okay. I'm guessing you would agree. If you look at this, you know exactly what it means. All real numbers besides 5 and 6. If you write negative infinity to 5 union 5 6 union, you kind of have to think about it. Hey, what is it talking about? And then you might graph it. Oh yeah, I see what's going on now. Okay, so this is the preferred way of doing it. I want you to do it this way. The other way, you got to think about it, what's going on. So this is much easier to think about. And number 2 was also pretty straightforward, 10/3 to infinity. Okay, so again for quizzes, please put your first and last name and all your team members' first and last name. I may have let it go this time. I might not let it go next time. Okay, because if you only put your name, then I have to kind of look at all the others and figure out who's in your group and all that stuff. So I may not be as generous next time. So even if you got the question or questions correct, if you don't put your other team members' first and last name, I may take off points for that. Okay, not just the first name. I got my class list alphabetized by last name, so if you only put the first name, I still got to search around for, who's in your group. Okay, so best thing, my suggestion is, once I give you the quiz, right, and you are in your breakout groups, immediately put your first and last name, and then, you can see everybody else's name, then put down, everybody else in your team's name. Then that's over and done with, and you've got it all set. So you got the first and last name, and you're good to go. Okay. I already emailed you back your score. Almost everybody got a 5, so that's the way you want to do it. Okay, so every quiz will be like that. It's pretty easy, folks. You have to admit. Okay, which means the majority of you are getting an A right now because you got 100% on everything. If you're showing up every day and you got 5 out of 5 in the quiz, you're getting an A. Okay, so you get the quiz question correct. Then don't leave. Make sure that everybody else in your group has it correct, and then you can leave. And then get your cell phone and click, email it to me. You've already done one, so now you know what it's all about. And all the quizzes going to be like that. Okay, so it's not that hard to get full credit on the quiz, folks, and it's also not that hard to get full credit on a participation. So you might say, is there extra credit? In my opinion, quizzes and participation are already kind of like extra credit. Okay, so something similar this Friday. Same thing, we'll have another quiz, but the week after will be our first exam, right? So it looks like February the 5th. So every Friday is a quiz, exam, quiz, exam, and so on, right? Except we have a 4-day weekend coming up where, yeah, Thursday will be the quiz instead because we don't have school on Friday the 12th or Monday the 15th, I guess. Okay. All right. So that's about it. We are up to 1.3. Here's the calendar. We're slightly ahead. So I was originally only supposed to do 1.2 today. I'm already done with 1.2. So anything I do is extra. It's just gravy from here on out. Okay, so I'm going to go to 1.3. And then I might give you another one of those quick answers before you leave. Just type it in the chat what you think the answer is. And I'm not going to dock you if you get it wrong, but I want you to at least try, and then you can just go ahead and leave. Okay. All right, so 1.3. I did very little last time, so let's do more. Okay, again, hopefully everything is review from before. So going through quickly, new functions from Ode, page 37. Okay, so remember this from pre-calc. Y equals f of x plus c. C units upward, f of x minus c, c units downward, f of x minus c, where the x minus c is in parentheses, that's c units to the right, f of x plus c, c units to the left. These are the rules for stretching or shrinking. C f of x, stretch vertically. And maybe I should think in terms of a trig function, you might recall from trig. So you have sine x, 2 sine x, right? That moves the graph 2 up, amplitude 2. Second one, 1/2 sine x, that shrinks it, right? F of cx, well, that's like sine 2x. Okay, that shrinks the graph horizontally, that changes the period. This would be like f of x is sine half x. Negative a function, reflect across the x-axis. F of negative x, reflect across the y-axis. By the way, you're welcome to put any and all of this on your cheat sheet. Of course, you only get one 8.5 by 11 sheet of paper, so you know the more you put in the paper, the less you have for other stuff. All right? Okay, so I think we're ready to get started. So 1.3. Now I'm showing you the book, so I can't really write and show you the book at the same time. So I'm afraid I'm not going to be able to write any of this stuff down. So you just have to listen and write it on your own. Okay? And so you're given a graph of f of x. Okay, so I can't write it. I'll say it, but you write it for me. Okay, so what happens for each of the following? A, shift 3 units upward. 3 units up is f of x plus 3. Right, so if you want to write this in your notes or on your homework, actually, because this is a homework problem. So that would be f of x plus 3. Can you guess B? 3 units down. F of x minus 3. Okay, C and D. Look at C and D. 3 right, 3 left. Okay, this is what I sometimes consider counterintuitive. It's kind of against what you might think. Okay, so 3 to the right, it's f parentheses x minus 3, where x minus 3 is all in parentheses. Okay, again, f parentheses x minus 3. Sorry, I can't write it and hold the book up at the same time. F parentheses x minus 3. But once I have that, you know what D is. It's f parentheses x plus 3. And of course, the answers are on the back of the book. Okay, E and F reflect about the x-axis. So you know there's going to be a negative somewhere. So E, reflect about the x-axis. So anything above the x-axis goes below. So that would be negative f of x. So again, E is negative f of x. How about F? F also has a negative, but where does a negative go this time? F of negative x. Right, f of negative x. And G and H, stretch and shrink by a factor of 3. Okay, so think of the sine function like sine x. What happens when you put 3 in front of it? Well, it stretches it out, right? So G would be 3 f of x. Again, 3 f of x. And H would be 1/3 f of x. 1/3 f of x. Okay, so sorry I can't write any of this down. Hopefully you got all that. You can listen to the video later if you wish. Okay. Okay, 3. The graph of f of x is given. Match each equation with its graph and give reasons for your choices. We're not going to worry about giving reasons for the choices. We'll just do it. Okay. So we'll move some stuff around here. Okay. Number 3. Do you see the blue graph? It's f, right? So what happens in each of these cases? Okay. I'm trying to raise it up, but the book is heavy, as you know. Okay, A. F parentheses x minus 4. So what does that do? Moves 4 to the right. Okay, so which one is 4 to the right? That is number 3. See if you can read it there. Yeah, number 3. Okay, so A is 3. How about B? F of x plus 3. This one here. That moves 3 units up. So which one takes the blue up 3? Looks like number 1. Is that right? So B is 1. C, half f of x. I'm sorry, 1/3 f of x. I guess it doesn't change that, but 1/3 f of x. So it's a shrink. Shrinks by a factor of 3. So look at the blue graph. Which one is shrunken? It's number 4. Right? And then you have some more complicated ones. D. Okay, so we're looking at that and also that. Okay, so what does the x plus 4 do? That moves 4 to the left and then reflect across the x-axis. So imagine the blue one. Sorry, it's hard to hold it. Okay, take the blue one, move it 4 units to the left, and then reflect across the x-axis. So that looks like number 5, right? You can imagine a blue one. I can't point it to you because I don't have any more hands. But if you move it 4 to the left and then reflect across the x-axis, you get 5. Okay, and so by elimination, the only one left, I guess, is what? E would have to be 2. So let's see, that one would go 6 left. Okay, it looks like it's 6 to the left, and then it's expanded, stretched out by a factor of 2. Okay, so E would have to be 2. Okay, I'm going to put the book down because it's very heavy. Okay. All right, so that's those. Let me quickly check the chat. Let's see. Exams are individual. Okay. Yeah, as you might expect. All right. So yeah, unfortunately, you'll hear me say quite often this semester, the book is heavy. I'm raising it up so you can see it, but whenever I do that, the book's heavy and all that stuff. All right, so now let's see. I did 1 through 4. Okay, 9 to 23 odd. Okay, there's a whole bunch now where you graph. Okay, you don't plot points. Okay, but just take one of the standard functions and then do something to it. Right. So you should already be familiar with basic functions like the squared function, basic parabola, cubic, trig function, and so forth. And then we're doing miscellaneous stuff to it. Okay, so I'll show you some of 9 through 23, I guess. Okay, so let me put the book down. Okay, so hopefully you did a lot of this stuff in pre-calc, right? You start off with a basic function and then do stuff to it. Okay, so 1.3, number 11, y equals x cubed plus 1. Okay, so first thing you want to ask yourself is, do I remember what does the graph of x cubed look like? Right, the basic cubic function. Now you know x squared is parabolic, goes like that. How about x cubed? X cubed looks like this one, the one I have in red. Okay. Notice I'm not even plotting points. I don't even draw the grid, like 1, 2, 3, 4, 5, -1, -2. I don't need to. I just want a quick and dirty graph. Okay, so the red is x cubed. And then we know when I put a +1, you just move the graph 1 unit up. So the final answer is in green, x cubed plus 1. And you should be able to show me something similar to me on an exam. Okay, I mean, if you got a graphing calculator, you can just punch it in your graphing calculator and ta-da, there it is, but you don't show me that you know it. Okay, so maybe on an exam, you would start off with as a progression, say, okay, this is what x cubed looks like, and then I move it left, right, up, down, stretch it, shrink it, reflect it, blah, 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 right? Okay, so you should be able to show me something like that. Okay, 15 was harder. There's a trick to that. 15, y equals x squared minus 4x plus 5. Okay, for that one, we have to complete the square. Okay, remember the game of completing the square that you've done many times before, hopefully. So x squared minus 4x plus 5. Complete the square. Okay, you say, how do you complete the square? So first, I'm going to separate it out. x squared minus 4x, keep it separate from the 5. Okay, and yeah, there's what it's supposed to be, and I changed the color on purpose. Okay, remember for completing the square, you take half the coefficient of x and square it. Okay, so I want half of -4 and square it. Half and square. Okay, and again, you're welcome to put that on your cheat sheet if you want. But remember, you can't put everything on your cheat sheet. Okay, so how much is half of -4? -2. That's the half part. Now square it. What's -2 squared? 4. Okay, so I put +4 and -4. Okay, you might recall maybe in your earlier work for completing the square, you added 4 to both sides. Well, here we're putting everything on the same side. So if it's on the same side, you put +4 here and -4 here. These two things that I haven't read, I've added 0. Okay, 0 being the additive identity means you're not changing the value of the expression, right? Whenever you add 0. So I'm adding 0 in the form of +4 and -4. Okay, so that way when you do this half and square stuff, right, one more time, half of -4 is -2. -2 squared is 4. So +4 -4. If you do it the right way, this is a perfect square. Okay, so again, here it is. Half of -4 is -2. -2 squared is 4. Okay, so this factors into x minus 2 squared now. And this is +1. Okay, so whenever you do this half and square stuff, complete the square, this thing is always factorable as a perfect square. Okay, so by completing that square, this is factorable. That's x minus 2 squared. Okay, and there we go. So my base function, my basic function is x squared. So I have my parabola, y equals x squared in red. Okay, and then think, what happens if I change x to x minus 2? That moves 2 units to the right. And what does the +1 do? Moves up 1 unit. So there we go. And the easiest way to do this, I think, is just take a very convenient point, like the vertex, the origin, 0, 0. Where does 0, 0 go? Right? So if I move 2 to the right and 1 up, it becomes 2, 1. That becomes the vertex. And then just quickly draw the graph. Right? So that's what I expect you to be able to show me on a quiz or test or the homework or whatnot. Right? So you say, oh yeah, I got x squared, and then I just move it 2 to the right. Okay? If I change x to x minus 2, 2 right, and then +1 means up 1. So that's all. Okay. All right, then 19. Y equals sine half x. So kind of a review of trig a little bit. So just a quick graph. Okay, so you might recall from trig, if you have y equals sine of bx, the period is 2 pi over b. Okay? If you want to put that on your formula sheet, you may. So 2 pi divided by the coefficient of x when you have something like this. Okay. So the b is a half. So the period is 2 pi divided by a half. 2 pi divided by half. Dividing by 1/2 is the same as multiplying by 2, is it not? Multiplied by the reciprocal. So the period is 4 pi. All right, so I'm ready to graph it. Before I do that, do you recall what's the period of just the basic sine function or cosine? Basic sine or cosine has a period of 2 pi. So this one has a period of 4 pi. So it's almost like, okay, imagine the sine function finishes the whole thing for 2 pi, and then just take that spring and stretch it out right here. So it doesn't finish one complete period until 4 pi. Okay, and I know sine function goes like this, right? So up 0, down 0. Okay, that's supposed to finish that whole thing up to 2 pi. So that up 0, down 0 should all be here, but it got stretched out. So now the period is 4 pi. So this is what it looks like now. Pi, 2 pi, 3 pi, 4 pi. That is one period of sine half x. Okay. All right, so that's what we have going on here. Okay. Any questions about that? put it in the chat. Okay, I wasn't going to show it to you. I'll just talk about it quickly. 21. Do you remember what absolute value looks like? Absolute value function? Absolute value function was V-shaped, was it not? Okay, let's see if they show you an example in the book. Okay, but I'm sure you had it in pre-calc. Take it back, maybe they don't show it. Okay, well, I can take a quick moment and show you that. So a quick timeout for the absolute value function. So it's V-shaped. Okay. So it's good to memorize it. Or again, if you don't want to, you can put that on your formula sheet. But you can plot points, 0, 0, 1, 1, 2, 2, 3, 3, right? But on this side, negative 1, 1, negative 2, 2, negative 3, 3, and so on. Okay, so I think you've all seen that before, absolute value of x. Okay. And now, look at 21, absolute x minus 2. So take that V shape, and then what happens? Move it 2 units to the right. Okay, 2 to the right. So that's all. Okay, 23 is a little bit harder. There's a lot of things going on with 23. Let's take a look at 23. Y equals absolute value of radical x minus 1. Absolute value of radical x minus 1. Okay. Before I show you what I have, do you remember what square root function looks like from pre-calc? Square root function. Okay, so I've got the progression here. Okay, so here's my square root function. Okay. You're only allowed to plug in non-negative numbers, 0 and positive, and the thing that comes out is a non-negative number. So if we were to plot points, it'd be 0, 0, 1, 1, 4, 2, and so on. Okay, that's the square root of x. Now, temporarily ignore the absolute value. I'll just cover it up with my fingers. Okay, absolute value of x, right? I apply this principle a lot. You maybe heard me say this. If you don't like looking at something, don't look at it. Okay, that absolute value confuses me. Well, don't look at it. How about just square root of x? Okay, I know that. Now, how about square root of x minus 1 like that? Ignore the absolute value. What happens to square root of x minus 1 like that? That drops the graph 1 unit, right? So 1 unit down. Okay, the picture's getting a little bit cluttered now, but just cover this. That's what I have now. Okay, so square root of x, look at this, 0, 0. Now I go down 1 unit, radical x minus 1. So this is the point 0, negative 1. This is the point 1, 0. Okay. All right, now I'll consider absolute value. Okay, so how do I tackle absolute value of this graph, or actually any graph? How to do absolute value of any graph? Now, the absolute value of 0 is what? 0. The absolute value of a positive number is positive, so it stays the same. Okay, so by putting the bars, these bars, any part of the graph that's above the x-axis stays, and 0 stays. So 1, 0, all the way out, that stays the same, right? Okay, so one more time. If I put bars right here, this part was already positive to begin with, and 0 stays 0. So whatever the absolute value of the graph looks like, this stays the same. Okay. Now, what happens to this part? Well, this part was negative. If I have it in bars, the negative becomes positive. So instead of 0, -1, I'm going to have 0, 1. That bounces over to here. Okay. So this part right here, this part reflects across the x-axis, which is 0 there. Okay, so 0, -1 bounces over to 0, 1. Okay, so the red is now the final graph. Okay. This part reflects, so imagine reflecting this piece here across the x-axis. This stays the same. Okay, and I've got a little representation right here, right? So it comes down like that and like so. Because I got so many things here, I thought I'd just redraw it again. So the red is the actual graph. Right. So this finally is the graph of absolute value radical x minus 1. Okay. So can you show me such a progression like that on a quiz or exam? All right. So start with square root of x, radical x, go down 1 unit, then absolute value, right? Absolute value. Anything that's greater than or equal to 0, i.e. above the x-axis, stays. The part that's below this part reflects across the x-axis and comes over here. So it ends up like that. Okay, get the yellow out. Okay, the problem's actually finished. I'll dig a little bit deeper for the absolute value function itself. Okay, y equals absolute value of x. Okay. You can apply that principle just for y equals x. So I'll tell you what, let me draw this in black. I don't want to erase the red completely. Okay, y equals x. Slope is 1, y units up to 0. It looks like that, right? Now, apply that principle of the absolute value here. Okay? Absolute value of x. Anything that's 0 or positive stays the same. So the part that's above the x-axis or equal to 0 stays the same. So that part stays the same. Right? Because for that part, the absolute value is the same as the number itself. So that stays the same. Okay? But now what about this part that's below the x-axis? The negative is going to become positive. So just like over here, okay, I will take the reflection across the x-axis of this piece, ends up over here. So you end up with your V shape. Okay? So you just take the graph of y equals x, okay, and this part bounces over to here, right? Any part that's negative bounces over to the positive side. This side stays the same, so it looks like that. Okay. Okay, so that's up to 23. What time is it? Now, I wasn't going to go that much longer, so I've gotten pretty far already. Maybe I'll show you. Let's see. Okay, so I'm done up to 23 odd. 29 to 41. Let me try to start you with 29, and maybe I won't go too much farther after that. Okay, so 29, please. Okay. How is the graph of y equals f of absolute value of x related to the graph of f? Sketch the graph of sine absolute value of x. Sketch the graph of y equals square root of absolute value of x. Okay, I'm actually going to not do A first. I'll do B and C first, and then come back to A. Okay, so sine absolute x, y equals square root of absolute value of x. Okay. So sine absolute value of x. Raise it up a little bit. All right. First thing I'll notice is what happens if I replace x with negative x? I get the same thing, right? If I put pi over 6 or negative pi over 6, it's the same thing because I'm taking the absolute value, right? So since I'm taking the absolute value, I'm going to get the same thing back. So this automatically becomes an even function, which means I'm going to have symmetry with respect to the y-axis. Okay? If I plug in negative 43 degrees or positive 43 degrees, it's the same thing because when I take the absolute value, it's the same thing, right? So here's a rationale for the graph. From what we said before, if x is greater than or equal to 0, again, x is greater than or equal to 0, then it doesn't matter if I have x or absolute value of x, it'll stay the same. Okay. So this part over here stays the same. That's just a regular sine function. Because I plug in 0 and pi over 2 and pi and 3 pi over 2 and 2 pi. It doesn't matter if it's positive or negative because I have the absolute value. So that stays the same. So this is sine of x. Yeah. So how is that different from sine of absolute value of x? On this side, there is no difference, right? Because if x is positive, then the graph's going to be completely identical. Okay, now what if I plug in a negative value? Well, we already said that. If I just take the regular sine function, it's going to go down and up like so. But instead, since we said this is an even function, I'm going to have symmetry with respect to the y-axis. I will take the mirror image of this part and end it with this. So I get this funny thing. Okay. So again, the part that's greater than or equal to 0, graph that exactly the same. And then if this were a regular sine, it would come down, right, and go up. But because I have absolute value, we already know it's an even function, which means I have symmetry with respect to the y-axis. So I just take the mirror image here. So don't look at the regular sine function. I just reflect this piece across the y-axis, so it ends up looking something like this. Okay, a little bit tricky. Now, we apply the same principle for y equals square root of absolute value of x. I've already shown you the picture, but pretend you don't see the answer. Okay. Maybe I'll start off with this. If I only have square root of x, what's the domain? I'm only allowed to take the square root of what kind of numbers? Greater than or equal to 0, right? Oh, we just did that over here, right? Here's square root of x. Okay. So if I have square root of x, I'm not allowed to plug in like -1, -2, -3, and so on, right? I am allowed to plug in 0. Square root of 0 is 0. Now, put the bars. Now what real numbers can I plug in? Anything. Because even if I were to plug in a negative number, which is not allowed over here, right? You can't plug in -4. You can plug in -4 here because you're going to take the absolute value and it's going to be 4. So the domain of this one is all real numbers. Essentially, yes, we play the same game as over here. Okay. So we say to ourselves, okay, first, for quadrants 1 and 4, whether it's here or here, the graph is the same. So y equals absolute value of x, we know it looks like this, right? So 0, 0, 1, 1, 4, 2, 9, 3, or whatever. Okay. So if I didn't have the bars, just square root of x, this is the graph. I mean, it's exactly the same as this. Is that right? Now, because of the bars, I am allowed to plug in negative numbers. And whatever I plug in for -1 is going to be the same as whatever I get for 1. -2 and 2 will be the same. -3 and 3 will be the same. -1,000,000 and +1,000,000 will be the same. So once again, I just reflect across the y-axis. So I get this. All right, now I'm going to go back and answer A. How is the graph of f of absolute value of x related to the graph of f? Here we are. So the graph for x greater than or equal to 0 stays the same. Then reflect the graph across the y-axis. Okay, so I'll hold this for a while. If you want to write it down or take a picture, or you can always look at the video later. So I'll hold this for a few seconds if you want to write it down. But basically, I'm done for today after this. So the graph for x greater than or equal to 0, so anything in quadrants 1 and 4 stay the same. Then take that graph and reflect across the y-axis, and that'll give you the graph of f of absolute value of x. Okay, so that's what happened over here. I just take the part in quadrants 1 and 4, where x is positive, and then just go like this, right? Same thing over here. Take the part where x is greater than or equal to 0, draw the graph as usual, and then reflect across the y-axis, and you've got it. Okay, and there we go. Okay, folks, I'm done with class, actually. I was going to give you one of these in-class assignments where you just type the answer that you can read. Let me check the chat real quickly. And if anybody else has a question before I give you that, please address it now or put it in the chat. Let's see. Okay, the problems of the homework are all in the syllabus. Okay, absolute value. The absolute value is not allowed to be smaller than 0. That's correct. Okay. Okay. So again, some of you are asking for all the problems of the homework. Okay. Well, here they are. It's in the syllabus. Okay. I've sent the syllabus many times. Some of you got it 3 or 4 times. Okay. So I emailed you the syllabus before. But it's all there. If you just want all the chapter 1, here it is. Worst comes to worst is on this video. I'll tell you what. I'll even go like this, and there. You've got all the problems for the whole semester. Okay. Absolute worst case scenario. I never got the syllabus. Well, here, I never got the homework assignments. Here, it's all in this video also. Okay, so I'll give it to you all here. So that's that too. Okay. Anybody else, please? That's it. Okay, so now I'm going to give you the questions. It's from the book. I would actually prefer, well, if you have the book, you can just go off the book. But if you don't have the book, take a picture on your cell phone, maybe, so I don't have to lift this up so high. Okay, just type in your answer, and then that's your pass to leave if you want in the last 7 minutes or so. Okay, so right now I'm on page 42. I want you to answer 2A and 2B. And this book is heavy. I don't want to hold it that long. Okay, so 2A, from the original graph, what happens to A? Y equals f of x plus 8, like that. And y equals f parentheses x plus 8. So just put down A. Okay, I'll say something which is wrong. Move 8 units to the left. So something like that. And then B, I'll say something was wrong. Move, 8 units, down or something like that. Okay, what I said was wrong, but that's all I want you to write. Okay, so 2A and 2B. Please take a picture, or if you've got it, then just go with it. Okay, I'm going to hold it only a few more seconds because this is heavy. So 2A, 2B, move the graph, blah, 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 blah. When you finish, you may leave, and I'll see you all tomorrow. And if you have a question, you can put it in the chat or unmute yourselves. Okay, just a few more seconds, and I'm going to put the book down because it's too heavy. So just 2A, 2B, move the graph, blah, 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 blah. Okay, you're not going to be docked necessarily if you get it wrong. This is part of learning, but I want you to at least try it. And I can look at the chat later and see who actually did it and who did. Okay, that's it for that. And you can put it in the chat, and I'll see you tomorrow. So I will stop the share, and I will stop recording also, because I don't need to.